Hey everybody, I hope you're all doing well. Today we're going to talk about circles lesson number 4. There are 5 lessons in the circles chapter. We are on the 4th one, and we are talking about how to figure out segment lengths. We've been doing angles over and over and over again, and now it's time to talk about segments. Now, there are 3 rules that you have in front of you here. If you downloaded the notes already, hopefully you'll have that in front of you and you'll be able to jot things down as you go. We've got 3 rules. And we're actually going to start with rule number 3 because it might just be the easiest rule you do all year. I think it's actually a pretty cool rule too because I wouldn't have necessarily thought it was true until you start testing it out and you realize this is one of the most convenient, basic rules that we ever do. It just needs multiplying. So here is the rule. If you have 2 chords and they are both completely inside the circle, then the pieces of one chord multiplied together equal the pieces of the other multiplied together. So basically, long story short, A times D equals B times C. That's it. So if you look at question number 1, when it's asking you to fill in the blanks and then find the value of x, I left these question marks in here just to annoy you. I get to delete them, you don't. Take a look. So we have x. What is the other piece of the chord that goes with x? Well, it's the piece that has the 3 on it. So x times 3 equals 5 times, and then you look and you ask yourself, what is the other piece attached to the 5? And you're like, okay, well, x times 3 equals 5 times 9. There you go. Now, at that point, if we try to clean up this mess and just try to solve the equation real quick, you end up getting 3x equals 5 times 9, which is 45. You get x equals 15. So again, this is one of my favorite rules. It's one of the easiest ones we do all year. You just take the pieces that are broken up and you multiply them. So x times 3 equals 9 times 5. That's it. That's all you got to do. Let's try number 2 here. Make sure we know what we're doing. 6 times 4 equals 3 times x. Now, when you try to clean up that mess, you're going to get 3x equals 24, which means x equals 8. That's it. That's all you got to do. Okay. So that pretty much takes care of how we do rule number 3. We'll get it out of the way early because it's the easiest one we do. Now, I want to talk about rule number 2 next. And the truth of the matter is, rules number 1 and 2 are the same. You don't necessarily think of them as the same. They don't look the same, but they are. And I'm going to show you how that relates here pretty soon. Rule number 2 says that if you have a segment that has a part on the inside of a circle and then another part on the outside of a circle, you could do A times C, and I'm going to explain this here in just a second, equals B times D. So basically, when you look at the way this formula is written, there are 2 parts to each segment that we need to use. A is the part that's on the outside. Then C is the entire distance. And you look, the other part of the equation does the same thing. B is the part that's on the outside. D is the whole thing. So basically, the outside times the whole thing equals the outside times the whole thing. which gives it the name ow ow. So this is sort of like getting punched in the stomach, which some of you sort of feel that way anyway with all the changes that are going on. This is the ow ow theorem right here. The outside times the whole equals the outside times the whole. Okay. Now, rule number 1 is the same thing because sometimes the outside is the whole thing. And if that's the case, then you would just multiply the same number by itself, which is where the square comes in. So in reality, rules number 1 and 2 are the same rule. It's just a different way of looking at it. All right, so I want to actually bring up, I'm going to actually start on question number 5, and then we'll come back to some of the other ones. On question number 5, let's start with the red segment right here. The outside is 3. The whole thing is x. Now, if you go to the blue segment, the outside is 5. The whole thing has a 5 and a 10, so the whole thing is 15. So again, we're doing ow ow. The outside times the whole equals the outside times the whole. Ow, 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 ow. So when you work through and you actually try to do the math, you get 3x equals 75, which means x equals 25. Okay, let's practice that exact same idea again with number 6, and then we'll do one of those squared problems, and I'll explain how it all fits in. Number 6, let's start with the red segment. The outside is 3. The whole thing is x. Then you go down to the blue segment, and in the blue segment, the outside is 4. And the whole thing, you've got a 4 and an 8, so the whole thing would be 12. So now you set up the equation. 3x equals 4 times 12 is 48, so x equals 16. All right, so let's talk about how the squares fit in. How is it an ow-ow problem? How is it an ow-ow problem if there's a square in there? Well, take a look at the red segment right here. The outside of it, so the part that's outside the circle, has a length of x. But in this case, isn't the whole thing also x? If the outside and the whole are the same thing, then you're really just multiplying x times x, which is where the x squared comes in. Okay. Now let's look to the blue segment here. We're going to use our standard procedure. The outside is 4. The whole thing is, well, if you've got a 4 and a 12 put together, the entire distance is 16. So we go through, and that's going to give you x squared equals 64. 4 times 16 is 64. And so, of course, if x squared equals 64, that means x equals 8. All right, let's go through another one just like that. Once again, whenever you see an x squared in one of these formulas, that means the outside and the whole are the same thing. So in the case of this problem, the outside is x, but the whole thing is on the outside. It never actually made its way inside the circle. So the outside is x. The whole thing is x. So x squared equals, the outside is 2. The whole thing is 16 plus 2, which is 18. So you end up getting x squared equals 36, which means x equals 6. 6 squared is 36. All right, let's practice these rules a few more times here. They're sort of scrambled. We've got a few different things going on. So let's go try them all together here, starting with number 7. So once again, now if you look, we've got our segments, and our segments are all completely inside the circle, which means we're just going to go to our first rule, one of the easiest rules we do all year. Like I said, 6 times 10 equals 5 times x. Okay, so let's set that up. 6 times 10 equals 5 times x, which I'm just going to write as 5x. 6 times 10 is 60, which means x equals 12. All right, let's try this again. 8 times 3 equals 6 times x. Well, that didn't seem too bad. 24 equals 6x, so x equals 4. All right, now I'm going to save problem number 9 because it is probably the only one that's really going to make people think. So we're going to jump right to 10 now. Number 10, if you look, now we have some parts that are on the inside of the circle and some parts that are on the outside, so we're going to have to do the ow-ow theorem. All right, so if you look on the top line, the outside part is 5. The whole thing is x. If you look on the bottom segment, the outside part is 6, and the whole thing is 6 plus 4, which is 10. So 5x equals 60, so x equals 12. So outside times the whole. Ow, ow, ow. All right, number 11. Once again, we're going to have to do the ow-ow theorem. Let's look at that first line right here. The outside part is 3. The whole thing is 27 because you have an outside part of 3 and inside part of 24, so the whole thing is 27. All right, now, if you look at the blue line, there, the one with the X next to it, this is one of those special cases where the outside part is X and the whole thing is also X. It never actually made it inside the circle, so the outside is the whole, which means the outside is x, the whole thing is x. X times x is x squared. Now, people sometimes freak out about that one, but it's actually not that big of a deal because x squared equals 81, which means x equals 9. Let's try one more of those where the outside and the whole thing are the same here. If you look at, we'll go dark blue here. If you look at the dark blue line, it never actually makes it inside the circle, which means the outside is 12 and the whole thing is 12. Now, if you look down below, the outside part is x and the whole thing is 16. So if you try to set up this equation and solve it, you end up getting 144 equals 16x, which means x equals 9. So a couple 9s in a row right there for 11 and 12. All right, our last problem of the day. We've bounced around. We've gotten everything done. Let's zoom in here and let's talk about problem number 9. It's the hardest one because it makes you actually think. All right, so let's start with the green line right here. Now again, we have part of the segment being inside and part of it being outside, so it's definitely going to be an out-out rule. The outside times the whole thing. So if you look on the green line, the outside part is 4, and the whole thing is 11. Okay, so we're going to leave it like that. Now, what happens up here? We're going to make this last part red just like this. All right, let's go. So this is where people are going to get confused because the outside part is 3. It's pretty easy to see that the outside part is 3. But what's the whole thing? Well, the whole thing would be the entire distance from here to here. So the whole thing is actually going to be the 3 and the x. And so the way we're going to write that is we're going to put together the x and the 3. We're going to add them up, and we're going to get x plus 3. So when we go to solve, what we're going to end up getting is 44 equals, and then we're going to have to distribute that 3 out, and we're going to get 3x plus 9. Subtract 9 from both sides. Then you end up getting 35 over here and 3x over here. So I guess the last step here, we're just going to have to make sure we divide both sides by 3. And then please don't just think it's wrong because it comes out to a fraction. These don't always come out neat and pretty. In this particular case, x equals 35 over 3. All right, so hopefully you can see how we can really break this down into just a couple of rules. We've got the one for if they are just 2 chords inside the circle, and then the rule for if we have to go to the outside. So I hope this helps you out, helps you get started here on circles number 4. I covered up some of the problems on the back, so you only have to do the ones that you can see, the ones that have an emoji over them. You can just skip because we're going to try to work our way into this, and we'll go from there. Thanks for watching. Hope you have a great day. Take care of each other.